Hello, grade nines. I hope you're doing well. It's Mr. Krupe here. This is the second section of chapter 6 in our patterns and graphing um, chapter of our textbook. So this is called Interpreting Graphs, chapter 6.2. So I'm going to kind of do this video a little differently. As you can see, I've got the answers already included with the worksheet that we do in class. So here is the question. The value of a computer decreases over time as the table shows. So we can see that um, time goes in years up by 1, so 0 to 4 years. So when the value of the computer was purchased in dollars, it had a value of 2,000, so at 0 time. But as time goes on, we notice that the value of the computer decreased, or in other words, we call that depreciation. So it loses value. So now after year one, it went down $300. It's now down to $1,700. After year two, it went down another 300. Year three, another 300. And finally, after year four, it has a new value of $800. It lost another three. So it lost in total about $1,200, right? So the first question is graph it. So here's the graph, and I just want you to pay attention to some really key points here. When we're graphing, you always, even though you're given graph paper, you always draw your y-axis in, and you always draw your x-axis in using a ruler. So we never graph without using a ruler. So straight line edges, you graph with a ruler. Notice also that I have chosen to label the x-axis time in years and the y-axis value in dollars. You can either put that on the top like this, on the top of the axis where the arrow is, or you can actually even write it on the side. So value could have been written here on the side, or at the very bottom, time could have been written underneath. So then I labeled the time. I went up by 1 year. Notice though I skipped a line, then I went one, skipped another. So I've got like in between, I've got a half a year in between each 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Common mistake students make is they use these numbers when graphing. They just kind of stick them on there. But notice what I did. I knew that my largest value was $2,000. So I knew the highest value I had to reach from zero. I had to go up to 2,000, and I chose, instead of going up by $1, I chose to jump by $200. So I skipped a line and I went 200, skipped another 400, etc. Basically, every line is $100, right? So 0, 100, 200, 300, 400, 500, 600, etc. until I reached 200. Then I graphed my points. So at 0, 2000 was graphed here. You can see the points have been graphed, the 5 points here. And I drew a straight line all the way through. Okay, so that's how you would graph this equation. Then here comes a question about interpolation, and I hope you watched my video on what does it mean to interpolate and extrapolate. So you notice that I had to use interpolation to determine what the computer was worth at $1,000. Interpolation means reading between the points, not beyond the points, because that's extrapolation. So interpolation of 3.3 years. Notice I've got a dotted line at 3.3 years, and I drew that dotted line, I drew that dotted line all the way up until I hit my straight line, and then I went across and I read the value. Sorry, 1,000 was here. So at $1,000, I read and I interpolated this way, and then I went down and I read that line where I reached my x-axis. It's three. I estimated 3.3 years. Okay, so that's how I interpolated to get this value. This question said use extrapolation to determine when the computer appears to have no value. In other words, when does it become zero value. Zero value is right on this line, right? So you notice I drew my line up to the 5th point, but then I added this piece on right here, and I went all the way down till it hit 0. So at what time is that? So that looks like down below, it would be like about 6.6, maybe 6.7 years, right? To figure out that it has no value at that point. You might as well just keep it or try to sell it on Kijiji or something. Next question, interpolate the value of the computer after 1.5 years. So at 1.5, I find it below, so 1.5 is right there, and I notice I interpolated. I drew a dotted line all the way up to the line that I graphed, and then I went across, and there's my point right there. What value is that? I estimated it to be 1550. Okay, so it's okay just to estimate when you're using your graph, and I ask you to use your graph to either interpolate or extrapolate. That means you're just estimating using your graph, and hopefully your graph is accurate, so your estimates should be pretty close. They don't have to be bang on, but just close. Okay, and finally here, is it appropriate to join the points with a straight line explain? So in this case, it is appropriate because you need to look at the values of time. Can you ask yourself, can time be can there be points between these 1, 2, 3, 4, 5? Is it possible, for example, to estimate 4.5 years? The answer is yes, that's totally reasonable. If this was, for example, the number of books, well, then you can't have 4.5 books. So it wouldn't be appropriate to really interpolate that. But in this case, time is a value that you can have halves, thirds, quarters, in betweens, right? Over here, value, is it appropriate to have values of half, like in between dollars, like $201.50? So 50 cents, yes, you can have half dollars. If this was the number of books, for example, then no, again, you can't have half books. You can't sell half donuts or half pies. So certain values you cannot have half of or thirds of, quarters of, but in this case, it is totally appropriate because yes, you can have decimal values for time and for money. Okay, so that's the first question on chapter 6.2. Here's a question about a weather balloon. That was the air temperature was recorded at different altitudes. So as the table shows, the altitude at 350 was 11.4 degrees. And as you can see, as the altitude increases, the temperature decreases. It gets colder as the balloon gets higher. So by the time you reach 1800 meters, this is meters of altitude, the degrees Celsius of temperature has decreased to -10. It says graph it below. Well, now we have negative values. How do you graph it when you're given a graph paper? So here's how I graphed it. Notice that my 0 on my time is here, and I drew my y-axis as time. My altitude, I didn't place it at the bottom. I placed it in the middle, like so that I could get values above 0 and below 0. Okay, so notice that I knew my highest value for altitude was 1800. So I chose to go up to 200 because I wanted to go beyond 1800 just in case I had to extrapolate and go beyond the points. So I chose to go up. Every line was 200. So 4, 6, 8, 1000, 12, 14, 16, 1800. There's where my points stop. But notice that I thought it would be a good idea to go beyond 18. So I just kept going up to 2600 and I still had room here. With temperature, notice I only went to -10. The table only goes to -10. on the negative side and 11 on the positive, but I look at my numbers here, I went beyond. So I chose to go up by 2. So 2, 4, 6, 8, 10, 12, 14, 16, and then I went down to get to minus 20. And I graphed my first 5 points, so you can see them, one there, one there, one there, one there, and one there. And then I drew my line not only through them, but I went beyond and I drew it even further down. Okay, so that's very important that you kind of give room to go beyond the points that are given on this table, as my lesson previous to this showed you. Okay, so here we go. It says interpolate the approximate value for the air temperature when the balloon is at 600 meters. So here's 600 meters. Notice I interpolated between the points. I drew a dotted line up to the graph line, and I went across, and that looks like it's past 7, right? So I estimated 7.2. So I think the actual is 8. So I'm off, but again, I'm just using my graph, so I'm just estimating. Next question, interpolate the value, approximate altitude of the balloon when the air temperature was negative 7.5. So I found negative 7.5 to be right there. You can see I drew a dotted line going across, and then I hit the line and I went up, and it looks like it's just past 1600. So I just estimated 1625, and I actually calculated the actual to be 1650. So that's not a bad guess. Okay, letter D says extrapolate the air temperature at 2500. So 2500, here it is, 2500. So I had to go down to the line, right? I had to hit the line that I graphed, which is here. So I went down, 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 and I noticed it struck right here when the temperature hit minus 20. And the actual is minus 20. So my graph seemed to have straightened out and been pretty accurate. Okay, so that's called interpolating and extrapolating, just reading points off of the line that you graphed. Okay, so is it possible to extrapolate the precise value? Precise means with precision, with total complete accuracy. Can I interpolate the air temperature when the altitude is 1050.92? So 1050.92 is somewhere there. Can I interpolate it? I can interpolate it, but with precision, and it says explain this. So my graph is probably just too small to be precise. I should probably enlarge this by 4 times so that I could give a more, exact, precise value for that temperature. Right now, it looks like 1050 is somewhere like between 0 and 1. It could be like 1 degree, right? But I can't really tell because my graph is too small. So with precision, it should be bigger. Okay. So anyway, that's my lesson on interpolating and extrapolating, or in other words, with interpreting graphs, chapter 6.2. If you have any questions, please contact me at jkrupe@lssd.ca, and I can give you more help from there. Thanks, guys, and take care.